So what we're going to do is we're going to go ahead and we are going to take a look at some problems where just adding down might not necessarily work. Okay? Like for instance, if I were to look at this one and I'd say, okay, let's do like what we did yesterday. Let's just add down and see what happens. Well, 2x and 1x would be 3x. And negative 4 plus 3 would be negative 1. Oh, this isn't working well for me. I still have x and y, okay? This one doesn't work to just add down. Sorry, I feel a loud boom there. So what happens if this doesn't work? What can I do? My job here is going to be, I need to create it so it does just cancel when I add down. So what I typically am going to do is I'm going to go through here, sort of like we did when we were doing substitution before, and I'm going to try to find something that has just a plain old x or a plain old y. And the reason I want to do that is that's the easiest one to be a little bit flexible with. So like for instance here, I'd like this x to be negative 2x. Well, why negative 2? Because I see a positive 2x above it. So if I have positive 2 and negative 2, they'd cancel. So the way I fix that is I multiply my whole bottom equation by that number I want this to be, negative 2. And I'll distribute it all the way through to every single one of my terms, because then when I get to the end, and I guess I did the work here, now I do have positive and negative 2x that are going to cancel each other. And then when I add down, it does turn into just like yesterday, where I can get down here, I can solve for y, and then plug that y value back in and get an answer. Is this probably going to end up being the longest of the three ways we're doing it? Yes. Okay? But sometimes we've just got to be able to deal with it that way. So let's get in and do some of these and kind of see how this works. So I look here and I go, okay, if I add down, no, nothing's going to go away. And I always want to check that, because sometimes that still may happen, that I can just add down and one of my variables will disappear. But if that doesn't happen, I'm always going to be looking for that x or y that's just by itself. Okay? Once I do that, now I start asking myself, okay, so if that's the one, that's positive 3x. If that's positive 3, what's its opposite that would make it go away? Negative 3. But here's even the kicker on this first one. This is kind of scary. Okay, so I want this to be negative 3x. That's my goal. Well, it's already negative x. So what number do I have to multiply this by to turn it into negative 3? 3. So I'm going to multiply through this bottom equation by 3. Now here's the weird part. I'm going to leave the top equation alone. Not going to do anything to it at all. But this bottom one, I've got to multiply that 3 all the way through. So negative x times 3 is negative 3x. And even the other terms, 3 times 3 is 9. 3 times negative 5 is negative 15. So whatever I multiply to get that first one, I got to multiply it to everything. Because then it becomes exactly like yesterday. Where now if I add down, 3x plus negative 3x cancels. That's the whole idea. So I can get rid of one of my variables. 2 plus 9 is 11. And 4 plus negative 15 is negative 11. And the cool thing about elimination is once I eliminate one, it's basically just going to be one step. I divide by my 11. And I get my y value. Pretty slick. But remember with these, I have an x variable and a y variable. So this is good, but I still got one part left. So my second part, and normally I'm just going to take the top equation. Doesn't matter which one, though. I'm going to take, in my case, the top equation, and this one that I just got for y, I'm literally going to plug it in there and substitute it. Bless you. So if I move this up a little bit, all I'm going to do is substitute the -1 in for y. Okay, notice I didn't get rid of the 2. I'm just replacing the actual variable with its value. And then I'm going to start simplifying. 2 times -1 is -2. And I'm going to solve the 2-step equation that's left. And just work my way through that way. And I know it absolutely is going to test your patience and your detail, because I mean, one sign error somewhere and we can get messed up with this. But typically, and we've mentioned this all the way through, our answers are going to be written as a coordinate point. So once I get my answers set, I always do my x value and then my y, and that's how I'd actually write my answer. Because if I graphed it, that's where the lines would cross. So we really want to do that. If you forget, it's not the worst thing ever, but it's something we really want to try to do. Okay. So I look at the next one and I go, okay, well, I see just a plain x and a plain y. So which one do I pick? Doesn't matter. Typically, if I see x as an option, I'm going to use that. Okay? So there's my x I want to change. I see a positive 2x below it. Well, then I want that to be -2x, because I want these to cancel. So I've got a 1 here to start with. So what do I multiply 1 by to get to -2? -2. Okay, I'm going to try and squeeze this in here. So I'm going to multiply the top one by -2. And again, that negative goes all the way through, not just to my x. Because the whole goal here, I've got to keep the value of my equation the same, and by multiplying everything by 2, I do. But then my bottom one, I'm just going to leave alone. Because now I've got it looking the way I want it to. Because once I do that -2 that I multiply through by, -2 and positive 2x cancel, and that's the goal. We want to eliminate one of the variables. And I just add down. -2 plus -3. And again, if you need to go to the calculator to make sure we don't have a sign issue, I'm for it. 4 plus -9 is -5. And again, it's the little things. I'm multiplying y by 5. So I divide that out. Get my answer. Again, be careful with signs. And then I'm just going to go back like I did before. I'm just going to go back to the top equation again. Write that down. And again, this time I solved for y. So I'm going to plug that in where y goes. So we're kind of combining elimination and substitution on this. Put my 1 in there for my y. And then just minus my 1 to get to the answer, and I'm good to go. And again, once I've got both of them, I'm going to put it in a coordinate. X always goes first, just like in the alphabet. X comes before Y does. And I get to my answer. So even though I always want to check to make sure that if I add down, I don't cancel something right away. If I don't, that's going to be the easiest way for me to go after this, to kind of get some practice with it. Now, are there any other screwball things that can happen here? Oh, I found one. Number 3. You're like, Harty, you keep saying look for the x or the y that by itself. Well, there aren't any. That's true here. So I got some options. I can do one of two things. If I see numbers like this, and I can't really multiply 3 by something to get to 5, here's another choice you have, and some of you may like doing this on a lot of the problems anyway. I always have an option of occasionally I may have to multiply both equations by something. Oh dear. If that happens, here's what you're going to do. I'm just going to switch these coefficients, and here's what I mean. The 3, I'm going to move down here, and the 5 is going to move up here. Now when you start to multiply, you may notice something. You're like, well, wait a minute. 5 times 3 is 15, and 3 times 5 is 15. 15 plus 15 is not going to cancel. That's true. So you pick one of them, and we're going to put a negative on one of them. So you're like, I might have to multiply both equations? Sometimes. So like here, my 5 is going to multiply through to all of my terms. So basically, I'm taking something that's there and just giving it a little bit different of a look. Down here, remember, it's a negative 3, so I'm going to have a negative 3 that's multiplying through to each of those. And that's really the hardest part of this whole thing. Because once I have that set, now I'm just doing some adding. 10 minus 6 is 4. 40 minus 36 is also 4. And it's just a one-stepper after that. So if you can survive the multiplying part at the first, it's not going to be anything that's too bad. And then again, I'm just going to go back to my top equation. Once again, I have y. I need to solve one of these for x so you can actually see that that happens sometimes. But again, sometimes little things like having different colors to make things shoot. That's why I've always got the colored pencils in front. Or drawing an arrow on where something goes so you don't forget where it goes. Like put it in the wrong variable or something. So I'll plug that one in. If some of you are comfortable, you can do that on the first step instead. And now I'm just back to a two-step equation again. Work on getting my x by itself. Do my division step at the end. And put it back in as a coordinate. And I want to do one more on this side. I'm trying to figure out which one is best here. We haven't eliminated y yet. Okay, number 4 is a good spot to go then. So last one. I look at number 4. And I say, okay, I got a negative 1 right here. And I got a positive 2. I really would like that to become negative 2y, because then negative 2 and positive 2, they'd cancel. That's a good thing. So I've already got a negative 1 there, though. So what do I have to multiply negative 1 by to get it to negative 2? 2. So I'm going to multiply through that top equation by positive 2. So 2 times negative 1 is negative 2. 2 times negative 5 is negative 10. And finally, we get one where it's not going to be x that gets eliminated. 2x plus 1x is 3x. Negative 2 and positive 2 cancel. Negative 10 plus 4 is negative 6. And then I just do my one step to get x alone. Be careful with your signs. And then I'm just going to keep going back here to my first equation. Again, I could use either one and I'll still get the same answer out. Take my x value, because this time I got x solved for instead, so I got to make sure I put it in the right place. That would get me a different answer. And again, I'm just going to work through like I normally do, work on getting my y by itself, so I got to get that minus 2 out of there. And again, don't stop here thinking y is solved for. There's still a negative 1 there. So I'll divide by that. Lots of details. Life's full of them. This just kind of lets you prepare for them in a little different of a way. So again, keep this handy when we get to our next quiz and when we get to the unit test. Something that could come in handy to kind of help. But I want to help in a more direct way for right now. I'm going to jump over to our sheet here. So this would be, bless you, homework check 3, our second assignment in there. And note the little clue that it gives at the top. It says solve each system. Some can just be added. Others need to be multiplied first. So you're always going to want to test it out first to see, hey, maybe, just maybe, if I add down right away, one of my variables will go away. So I look and I'm like, okay, so 2x and 1x is 3x. Negative 1 and positive 1. Ooh, negative 1 and positive 1y. Okay, they cancel right away. I'm not going to have to multiply this time. That's cool. Less work. So if you can do that on some of these, that's absolutely fine. Because then you're like, well, shoot, that was like one step, add down, I'm done. They all need to be this way, but unfortunately they're not. So I get that one, and I go, okay. Well, let's see. For my second step, I've been using the top equation. Again, either one would work. I'm going to take that x value, and I'm going to plug it in. So not only do I get to see visibly with the arrow where it goes, but if I decide I'm going to use a different color, it also kind of visually lets me see what I'm up to here. So I look and I go, okay, so 12 minus y equals 5. And now again, I'm just back into mode where I'm trying to solve that two-step equation. I'm trying to get the box by itself. So I'm going to do some opposites. And again, that negative 1, I'm multiplying it times y. So the opposite's going to be to divide. And then once I get that, I get my value and I'm good to go. So occasionally, I'm going to have that add down as an option. Now let's see. Is that going to happen every time? I don't think so. Let's look at this next one. 1 plus 4, that's 5. That didn't cancel. 1 plus 1 is 2. Okay, that didn't cancel. Anybody have an idea on what I could multiply one of those equations by to get rid of a variable? What's that? Okay, so if I did a negative 1, maybe up here on the top one, I'd have negative y here, and there's positive y. Okay, that's an opposite. If somebody would have said negative 4, I'd add negative 4x and positive 4x. So there's options here. It's not always just going to be one way that you necessarily have to do it. Negative times positive is negative. Negative times negative is positive. Got to be careful on those. Those are the ones that can get you. And then I'm going to leave the bottom one alone. And again, it's my y's this time, the negative and positive one, that cancel. That's a good thing. Negative 1 plus 4 is 3x. 3 plus negative 12 is negative 9. One step to divide. Which gets me my answer for x. And like I said, there'll always be one step left after this. I'm going to take that very first equation. Plug that x in there. So I'd have negative 3 plus y equals negative 3. Do my opposite, which would be to add 3 there. Negative 3 plus 3 is 0. Get my values. I want to find one more. Trying to see if there's any of those ones where I got to multiply both of them first. Number 7, I'm being told. Well, let's take a look. 7 could be a possibility. Let me look through, make sure there's not any others that could be kind of funny. Ooh, I'm actually going to jump all the way down here to the bottom. I'll come back up to 7 in a second. We'll do that one too. Let's do 14, and then we'll do 7. Then I'll let you be here for a bit to kind of play with some of these on your own, because you'll have 10 left then. So if I come down to 14, I notice 5 plus 2, okay, that's 7. That didn't cancel. 6 and negative 3, yeah, that didn't cancel. Can I multiply 2 by some whole number to get to 5? No, I can get a decimal, but I don't want to do that. What about, because I'm always looking at the smaller number versus the bigger one. What about 3 to get to 6? 2. So this time I'm going to multiply the bottom one by 2. And I don't have to do the negative this time because I already have one. So I'll leave the top one alone. The bottom one, I'll distribute my 2 through. And again, it's got to go all the way through, even to the side with the equals. Because if I forget that, that's going to get me in trouble. So the y's are opposites, and they cancel. 5 and 4 would be 9x. Negative 9 plus 36 is 27. Just do my divide, now be good for x. Then again, just me, I just like using the top one, because that way I never get any confusion on which one I'm plugging into. I have the x value, so I got to make sure I put it where x goes. So I get that in there. Simplify where I substituted in for x. Again, the goal is to get my y term alone. So I want to get that 15 out of there. We're going to have to shift up to here. So I got 6y left on this side since the 15's gone. Divide by 6. Just enough room. And I'm set. And then I think we said we were going to take a look at 7. And there are a few more on here that are just straight add down and something will cancel. Those are always nice. But let's come back up to 7 here for a second. Just so we can kind of talk how this whole idea works one more time. I always look and I'm like, okay, 5 plus 3 is 8. No, 3 plus 3 is 6. Okay, I got to multiply something. Can I multiply 3 by something to get to 5? At least not nice, no. Well, you're like, wait a minute. Well, 3 to get to 3 would be 1. But if I multiply it by 1, that's still positive. Yeah. I need that 1 to be a negative. Because then when I distribute all the way through, I get negative 5x, negative 3y, negative 4. And I'll leave the bottom one alone. So negative 5 plus 3 is negative 2. The y's cancel. We always got to have something cancel. Negative 4 plus 0 is negative 4. And x is going to equal 2. I completely agree. And then like we've been doing all along, I'm going to take that top equation. If you ever see one though that looks easier, I say use the easier one. Oops, I went a little far there. Plug it in for x. So I replace the x with my x value, the 2. The 5's still there. And I'm going to get a little tight on space here, it looks like. But again, it's always about getting my y value alone. The opposite of a positive 10 is to minus. We're squeezing and I'm hearing the answer. Y is going to be negative 2. And we're going to be set there. So again, always check first, because you're going to run into some situations where if you just add down, you're going to eliminate a variable right away. You're not going to even have to multiply it by anything else. But when you do, just figure out what do I have to multiply it by to get to the bigger number. And you should be in good shape. So again, if you need assistance, you can kind of refer back to this. If you want to see how it's going, you can check. We can look through them, see how it's going with that. And otherwise, you got about 15 minutes here to work with. So knock a few more of these out, because that way for some of you, when the next homework check comes, you're ready.